Hello, everyone. I'm meteorologist Sean Sublett, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has print and digital news operations in 77 locations across the country, including at my home base here in Richmond, Virginia. And I'm joined by my meteorologist colleagues across the country, Matt Hollander in Chicago, Kirsten Lang in Tulsa, and Joe Martucci in Atlantic City. Hey, everybody. I hope everybody is doing good today. Let's do a little round robin, see how everybody's doing. Joe, I know you just finished up, of all places, in a casino. Are you okay, man?
I mean, I didn't lose any money, so I guess I'm doing good.
That's about all we can ask. That's good.
No, I was actually here for a story that I'm doing about Superstorm Sandy 10 years later, and a lot of it was focused on messaging. So actually, it's quite fitting that we're talking about this podcast today. But we were with Gary Zakowski, who was the retired meteorologist in charge for the National Weather Service here. So good talk. Got to see a lot of people I haven't seen in a while. Always a good time here at Harrah's Casino in Atlantic City.
Yeah, Gary's a good guy. I met him a few years ago as well. Hoping to see him again soon. Matt, how are things in Chicago, buddy?
Not as fun as being at a casino, but enjoying a little bit of lull in the very active weather. I mean, I can tell you in the Midwest, I mean, it has just been one round after rain after another. I mean, we just cannot dry out. We might get one dry day and then it starts raining again. And sometimes it's just showers, but other times it's been severe storms. So there's been plenty of weather to talk about lately.
No doubt about that. And Kirsten, I know you've had the serious weather here very recently, right?
Yeah, last night, I'm coming off a late night with storms. Man, it has been Monday, we had around. Last night, Wednesday night, we had around. Now here we are on, we're recording here on a Thursday, and it's now finally starting to move out, and we'll get a little bit of a break. But there was a tornado that we caught just south of here, a little closer to Oklahoma City, actually, in a place called Seminole, and some pretty awesome footage coming out of that. But yeah, it's been busy.
Yeah, I don't doubt it. And with that, it's a good chance to go ahead and bring on our special guest, since we are in the core of severe weather and tornado season. Our very special guest takes that one step further for us. Kim Klockow-McClain from what I would call the capital of tornado research, Norman, Oklahoma. Kim is a research scientist with the Cooperative Institute for Severe and High Impact Weather Research and Operations. It used to be known as CIMMS, something shorter, but they've renamed it. That's at the University of Oklahoma in conjunction with the National Severe Storms Lab, NSSL. Her research involves behavioral science focused on weather and climate risk, specifically exploring how people perceive and ultimately react to severe weather risk and warnings and like that. Kim completed her undergraduate education at Purdue and her graduate work at the University of Oklahoma. Kim is my go-to when I want to understand how and why people are acting like they do when the bad weather is out there. So Kim, welcome to Across the Sky.
Thank you so much for having me. I'm glad to be here.
We very much appreciate it. Before we get rolling, tell us a little bit about how you got involved in this type of work, because if there ever was kind of a niche occupation, this is probably it.
No kidding, it sure is. We're still trying to figure out how to bring social sciences into our field. I think we know we want it, but people like me are a little rare and we have to be a little entrepreneurial. And when I was coming up there was no path for this. So I got into it by virtue of just being very, very fascinated, both by the environment, by the atmosphere, the weather. Growing up outside of Chicago, I was very impacted by the Plainfield tornado in 1990 as a young kid. And that what initially was fear turned into fascination, which becomes borderline obsession. And on it goes from there. As most meteorologists can attest, something gets us started down that kind of a path. And so I knew I wanted to pursue meteorology, but I also was really interested in human behavior. And early on in my life, that was a little bit of interest in like consumer behavior, marketing. How is it that we make persuasive appeals to people? I thought that psychology was really neat. And at Purdue, they didn't really have a marketing program per se. So I put it together by studying economics and psychology. And I just decided I'm going to major in meteorology and economics and see what I can do with this later. I have no idea where this is going to go. But then I found a research internship opportunity at the Severe Storms Lab in Norman. And there, it's called the REU, Research Experiences for Undergraduates program. And there was an economics professor here named Dan Sutter and Harold Brooks from the National Severe Storms Lab. And they were really interested in looking at the economic impacts of tornadoes. And I thought, wow, it's perfect. It puts it all together. And so through that start, I got really interested in the behavior of individuals who are reacting in situations of uncertainty and risk, and all the consequences of those decisions they're making. Some of them are economic, some of them are about saving and preserving their lives and making decisions for other people in these difficult situations. So it just led me straight down that path. And by the end of my graduate career, I had realized I'd started to uncover things that I thought, the social science could really speak to our field. But I realized that within our field, we just don't have a lot of ability to bring in the social science yet. That we're all trained as physical scientists, but we all have this mission to help people to make decisions. The goals that we all have are really implicitly behavioral. And the way I felt was that the weather enterprise just didn't have an ear on the side of their head to know how to hear the social science with, and I wanted to help build that. So I spent several years after my PhD in Washington, D.C., working as a congressional fellow and then working at NOAA headquarters to develop policy for social science research. Ultimately, I decided I just missed the research so much and I couldn't write one more of these documents that recommended, here are the research priorities, someone needs to do this. And I was just like, well, I'm just going to go do it. there aren't enough of us in the field to go around and get all these questions addressed. So here I am back in Norman, Oklahoma at my old stomping grounds, a place that's very, very friendly to this interdisciplinary scholarship, OU and the Severe Storms Lab. Wonderful, supportive place to build something that is a really new capacity. I have a social science team in a weather lab, and this is a first of its kind in the NOAA network, and we're really excited about it.
It really sounds fascinating because your point is very well taken. I remember coming up as an undergrad, we all want to send the same message as weather communicators, but we didn't spend a lot of time thinking about how those messages were being taken in. Get the message out, then it's up to the people to do what they're supposed to do. But then as I've gotten along in my career, and especially in this age of smartphones, you begin to see that different people take in the messages very, very differently. So one of the first things I think about, especially now that we're in the smartphone age, so we'll kind of kick off the conversation with this, Kim. I know that people, when they get a tornado warning, the first thing they want to do is try to verify it by a second source. Does that still happen in the age of smartphones? Are we starting to see things changing a little bit?
Yeah, this is a great area of study. There's a lot of conversation about, gosh, what do our warnings really mean to people? How do they get them? And then what do they do when the warnings are issued? We know in the meteorology side, there's not necessarily a lot of time to respond. So there's been a lot of conversation and concern about how do people use their time. That was actually a question I explored specifically in my PhD. I was looking at how do people understand risk space and manage the time they have, and how are they drawing in information over time. And I think in that exploration, I did see exactly that their confirmation, it's very, very common. It's something in the social sciences, we almost say it's irreducibly human for us to have a need to confirm the threat, unless we are specifically trained, and we do things like fire safety training, where you teach people just immediately react and respond to situations. Without very deliberate kind of training, it's hard to get people not to do that stuff. But what I saw was a lot of very effective confirmation. People were able to seek, if they saw, they were watching broadcast footage, they would seek additional information online to maybe fill in some geographic gaps, or try to get something a little bit more local, or they'd listen to police scanners to get very local information. The confirmation and the assimilation of information by very ordinary citizens fascinated me, because I think we underestimate in our field just how much people love weather. Not just weather geeks like us, but ordinary, everyday people are fascinated by this atmosphere that surrounds them just as it does us. And they feel a sense of empowerment by us with all the things we provide. And they're tapping into all that stuff. And they're trying to make judgments for their lives. And, those are things we can't do for them. They have to be in the driver's seat for a lot of that decision making. So I was really heartened to see what I considered a lot of very sophisticated confirming behavior and time management. And the only things that were problematic were when people didn't know how to read maybe the environmental signs. If you have like a really big tornado, people expect to see this Wizard of Oz tornado thing. And if you get a really big tornado, it just looks like a big wall of rain or cloud, and you can easily get rain wrapped tornadoes too. Those are the times where confirmation maybe is a little dicier for people, and we can really try to encourage people, I think, to just know what it is that you should be looking for. And maybe today isn't the day that you'll see something you think is classic. If we just know that's how people are thinking, we can speak to that. It's a really good question though, Sean.
Kim, do you find that geographically it changes as well? I worked for a little while in Denver, and Denver versus Tulsa, really any other kind of part of the country, I found a huge difference just in the fact that if there was a snowstorm coming, well, if that happened in Tulsa, people would hunker down and they would watch TV, or they would try to get their information somewhere. But in Denver, if a snowstorm was coming, man, they jetted off to the mountains, and it was like they're great, fresh pow pow, kind of thing. So I was, I kind of noticed that. I was wondering if in your studies you saw anything like that as well.
Yeah, this is an active area of research in the social sciences pertaining to severe weather and how people receive information about it, how they respond to it. We call these disaster subcultures. There are very different subcultures across our whole country, people who are very differently adapted to different kinds of weather hazards. In Denver, yeah, they're very adapted to snow. They don't even necessarily see it as a hazard most of the time. It is a benefit of living in Denver. People who live in Atlanta see it as a hazard. It is not a known benefit of living in Atlanta, not something they have adapted to. And so we see something really similar popping up in severe weather studies. We know that different places around the country, people are more likely to receive warnings when we send them. We're starting to see that places that are more tornado prone, people are more tuned in than maybe places on, say, the East Coast, where you get these things less often. And part of that is because we have a very, very practiced weather community here, a communication community that's putting out a lot of information and goes through this exercise of forecasting for severe weather and covering it, day after day, sometimes for months on end. But if you get to the East Coast, that's not the hazard that even we as meteorologists are handling all the time. And even our own infrastructure, just isn't doing as much with those hazards. And that works its way all the way through to the public then. And so it's a whole system challenge. But yeah, we totally do. We see very different subcultures, both on the public side and within our own field and in our partner communities. Emergency management, this is true too. There are some emergency managers who work with Storm Prediction Center information all the time. There are some emergency managers, especially in less tornado-prone places, that we're finding who don't know what the SPC is. And they are very unlikely to access some of this information. And so the relationships, they have to the weather community look very different, and the ways they make decisions are very different. It's a very good question. Geography is extremely important.
Yeah, Kim, this is Matt. The one question I've always had is how many people take action when they get a tornado warning? Because whether they get just a message on their phone or they're watching a broadcast meteorologist explain a tornado warning, there's very urgent wording in those messages talking about taking shelter, get into a interior room on the lowest floor. But I've always wondered how many people actually do that, because I feel like, this kind of comes back to the confirmation. Do people just hear that? They see an image, they read a text on their phone, and they immediately, all right, this tells me to go take shelter. I need to do that. Or do they actually walk outside their door, look around, look for the tornado? I've just always been curious, one, how many people take shelter, and two, how long it takes people to take shelter. Do they do it immediately, or do they do it only after they get a second confirmation? And then I also wonder, again, kind of coming back to, from a geographical standpoint, are people in certain parts of the country more likely to take shelter when they get a message like that? And does past experience have something to do? If they've gotten a lot of false alarms before, tornado warnings that didn't actually produce a tornado, for example, are they less likely to take shelter then compared to people who have perhaps experienced a tornado before? Then are they more likely to take shelter? So that's always interested me, is how many people actually follow the wording in those messages to take shelter.
Oh, you've asked so many great questions in all of that. These are really big questions that still are, some of these are still things that we're trying to do research on to really understand very well. I'll start a place that might surprise people, and it's with your last question. The last question is on, is there a false alarm effect? With experience of repeated instances where there perhaps is a tornado warning and not an experience of a tornado, whether that means you weren't hit personally or there wasn't actually a tornado with the storm. There are different ways one might consider what a false alarm is to a person. But no matter how we slice it, what do we see? And what we're coming to find is that sometimes in some places it seems to matter, but there's mixed evidence about it. There's some evidence that's starting to point to, even places where there are high false alarm ratios, there doesn't appear to be a lag in the reported willingness of individuals to respond to subsequent tornado warnings compared to places with lower false alarm ratios. Some of it might be about geography. There might be places where people have adapted to this idea that, especially if you're in the Southeast, that's a very difficult place to forecast for severe weather. The kinds of tornadoes they tend to get are more the QLCS, embedded rotations, maybe more ephemeral tornado types more often than what will happen in a classic plane setup. There just might be differences in how people understand what might be likely to happen to them, and that they adapt in different ways to false alarms existing. So we're still trying to unpack this question, but I think it's something that surprises the meteorological community that we have not unequivocally found that false alarms are like this huge driver of, oh, people won't believe you anymore, they won't do things. What we do tend to see in the studies that we do have, which, by the way, we don't have numerous post-event studies. This is something I want to come back to later in the podcast. We need a lot more data to address some of this after real events occur. That's part of the issues in the social sciences. We're really trying to create data collection instruments to get us at some of these questions. But we're seeing that situationally, you can have an environment that feels, people feel that oppressive environment, or, if it's a really potentially severe day, they're getting enough social cues that they're kind of like, what? Yeah, there have been false alarms in the past, but I still know that today is a day that I should pay attention to. So I'll let that bring me to your broader question that you asked first, which was about what is the propensity to respond? And based on the work that I've done, I'll again just remark on how impressed I am with people who have a lot of tornado experience in their local area. They kind of understand that tornadoes are a relatively small feature geospatially, and this is just a truism. If you were to look at the warnings that we issue, even in ones that verify where there are tornadoes, and let's remember, we have a 70 to 75% false alarm ratio, but even in tornado warnings that verify, at most, it's about 1% of the spatial coverage of a tornado warning that actually will experience a tornado, at most. So if you were to think about this from the perspective of a cognitive decision scientist, right? If you were to calculate the actual odds of being hit by a tornado, even given a tornado warning that confirms, it's not hugely high. So what people do is they do spend some time when they're in tornado warnings confirming. They will be looking at their environment. They'll be, seeking additional information. And given the long odds, I see that as a really positive thing. And ultimately, what I do see when I interview people who are actually in tornadoes is that maybe they only start sheltering in the first couple of minutes before a tornado hits, when the environment in particular around them starts to turn, or their town has been named specifically, in coverage. But if they are watching and monitoring for some period of time, they know where they're going to go. They've made their plan. They've probably prepared their shelter, and it only takes them 10 seconds to get there. So I didn't ever see it in the people that I spoke with as something that was a problem, but that was how I saw people managing their time, because they understood the underlying, challenge of the forecast problem. And so I take a largely positive view to that question.
So not so much when the tornado's coming, but before the tornado's coming. One thing that I even have a problem talking to people about is when you see on the Storm Prediction Center maps a 2% chance of a tornado risk. And people are like, well, what the heck is that? It's hard to explain. And do you think, what do you think, if anything, is better than showing something like 2% or 5%? Because inherently, those are very small risks. And to your point, a very small area is going to see it, but you still want to let people know, like, hey, 5% risk of a tornado is a pretty solid risk.
That's a great question. We're grappling with this very thing with a research program that's going on here at the lab, where we're toying with creating a host of different kinds of probabilistic products. So you've named one. The Storm Prediction Center has this outlook they put out that has storm type, probabilities of different hazards that can be experienced in a region in a given day. And we might build on that to have, probabilities over the next couple of hours in a region, or even for a particular storm, the probability that it could go on to produce a tornado or severe hazards. And so we're asking these very questions. How is it that people understand forecast uncertainty? What can we do to make probabilistic information really relatable? And to your question about SPC information specifically, we know in the meteorological community that, 2% or 5% chance could be a really big day. In fact, for some places in the country, that's the biggest day you're going to ever see. And, there are people who we see, especially in our user communities, like emergency managers, if they are seeing SPC information, they've adapted to that. They kind of get a sense for, they know, they have a gut feel. Even though they'll complain, they'll say these probability values on the surface, this isn't really, why did you guys do this to us? But they do understand that, the day could be bad. Part of it is because that information is paired with a category. So you put together that numeric estimate with, okay, so here's sort of what it means in a scale. We'll give you a scale. Now we know the SPC scale, there's some challenges with it. People don't necessarily perfectly always get the words all in order if we're, if we ask them to come up with putting 5 words in order. Here are 5 words. What's the order they should be in? They tend to get things a little bit confused. But even so, when you put the pair together, that tends to get the best comprehension. And that we're also finding now in some studies with our publics, that if we put together that sort of categorical label with the estimative probability value, if we're interested in just probability value alone, personally, something that I think is a really, really neat idea that we are exploring for all of our products is trying to make probability values that take a historic baseline into account. So instead of saying there's a 2% absolute chance for you today within 25 miles of a point, you could say today it's 10 times more likely than even an average May Day that you could get a tornado in your area. Something that accounts for your local historical baseline and puts the probability into a context that people can relate to. So you're trying to get it to, not just, all right, here's the 2%. You're trying to tell them what that means. This is going to be one of your top 10 days. This is a day that hasn't happened in 5 years. There are a lot of different ways that you can slice probability and offer that estimate that might resonate better with the ways people actually make decisions.
Yeah, this is Sean again. I think I've had that thought too, Kim. So I'm glad to hear you mention it, that if you put it in a different way, like this is the kind of day, if you remember like it was, 6 months ago or a year ago, remember that particular situation, this is the kind of situation we're up against once again. So thanks for that. I appreciate that. We're going to take a quick little break. Then on the other end of it, we want to talk a little bit about this day and age in social media and if that's had much of an impact in severe weather communication. So you're listening to Across the Sky podcast with Lee Enterprises. And welcome back to the Across the Sky podcast. I'm meteorologist Sean Subbott with Lee Enterprises Richmond Times-Dispatch in the Old Dominion. And we're joined by Kim Klockow-McClain from Norman, Oklahoma, National Severe Storms Lab, NSSL, CIWRO, all these acronyms, but basically she's studying how people react to severe weather. And it's very, very good stuff. Kirsten Lang, our partner in Tulsa, had to step out for a bit, but we definitely wanted to get this question in front of you before we bugged out, Kim. In this age of social media, especially the last 5 to 10 years, have you seen that impact weather communications and or how people are taking in severe weather messaging?
Yeah, this is really the big topic of the day. And thanks, Kirsten, for that great question. So many dimensions to the social media influence. One piece of this that you just asked about was, are we seeing a change in the landscape of how people are receiving weather forecast and warning information? And are people increasingly gravitating to social media? And the answer to this, it comes from some of my colleagues here at the Center for Risk and Crisis Management at the University of Oklahoma. In exploring this question, they find that there is an increasing share of people who are going to social media, but it's still not by far a majority, especially of people who are looking for warning information. If you're in an event in real time, people are turning to broadcast media still, traditional broadcast media like television and sometimes radio, and looking at their local siren systems for information too. They are still doing that by far most often. I think weather apps are becoming very common for the day-to-day forecasts that people are receiving. But we are seeing, even with traditional broadcast media being such drivers, we're seeing an increased shift into the digital space. Especially, you can break this down by age. This shouldn't surprise anyone. While what I said is true earlier of the general population, the youngest generation is increasingly turning to social media for that coverage in live events. And so it's becoming a significant fraction of the youngest generation. So we're really starting to see bifurcation in our populations in terms of the sources people are seeking to get information from.
And, I think it's great, the whole debate about social media and the good and the bad. And the one thing I see is when you get long-term forecasts, like when we start to see the potential 6-7 days out that there could be the potential for a severe weather outbreak, what I often see are some people post these kind of really scary forecasts for something that's almost a week out. I just wonder the effect that has on people, because there are sometimes when events like that do come to fruition, but there are lots of times where, especially people, a lot of times in those posts get very specific about locations that are going to see tornadoes. And very oftentimes that location with the greatest threat shifts. And I just wonder the influence that has on folks, and perhaps the fatigue and the anxiety that it has when you're talking about something where there's so much uncertainty for so far out, talking about 5, 6, 7 days out. I think there's a confusion in the public about how certain we are about the details of an event. And I just wonder if there's been any research that you found about how people are reacting to these long-range forecasts with very scary situations and how it's impacting the decisions they make.
Yeah, this is a really interesting and important area of current research. We are interested in the same things that you are with this. I think there were a number of important events that happened early in the existence of social media that made us all pause and find concern about these questions, there are people who may or may not have scientific training who get large followings on social media, and then, yeah, really far ahead of time, even well beyond the arc of a forecast, that scientifically will have skill. You'll see people make forecasts for specific points that could be very, very dramatic, or they'll pick out some particular deterministic model and pick out the worst possible solution and get people to freak out. And there have been real world consequences documented from some of this. There have been emergency management agencies that get inundated by messages from their publics asking about plans for evacuations, and that this can even confuse some public safety agencies that are involved in some of these events. And all of that, part of the central issue here is that we don't just have one voice, one authority in the weather space, and people in the public don't know our behind the curtain workings. They don't understand that there's this National Weather Service that has some set of official products, and there's this private sector entities that have these other set of value-added products. And even among those of us who have the credibility, there can be differences in opinion about the forecast owing to different scientific opinions about what's likely to happen. So all of that is getting just pushed into the social media space, where people are being asked to filter through it and respond and make choices. What we are seeing in some of the research that we're doing is just how extremely difficult this problem is to tackle. And this is not just something that our field is struggling with. Everyone knows in every area of science, there is this battle going on for the credibility and control of a message. I think your question about what are the effects of this on people, I haven't seen research specifically on that, but I think we would be unsurprised to find some of the things that you're concerned about, that we would be unsurprised to find fatigue that goes on, and at the very least, an exacerbating of the perception of false alarms, right? So what we're doing right now in the social sciences, when we're trying to figure out if there are false alarm effects, we're comparing people's subjective feelings about that to the objective actual baseline of what were the officially issued products. We're not accounting for what are the things that people were seeing in the rest of this social media fueled space, and trying to get a handle on that is very, very hard, especially after the fact. So these are really challenging research problems, and we can't answer your question fully, but I can say, to the degree to which false alarms may be concerning, back to our first conversation, exacerbating their apparent effect is not going to be good. Though we certainly do know that it won't improve trust, and should not be expected to improve the kinds of choices people are able to make for themselves.
Yeah, it's just very interesting to me. So I'd be loving to hear about any new research that's going on there. Joe, do you have a question?
Yeah, I do. And I've thought about this for about maybe 2 years. And then after Ida came through here at the end of August into the first day of September, really got me thinking here. So one of the things with Ida in New York City said that there was not really an expectation for the flooding to be that bad in New York City. And kind of, to make a long story short, passing the buck to the National Weather Service saying, hey, you didn't inform us that it was going to be this bad. Now, reality situation was the National Weather Service issued a high excessive rainfall outlook, which for everybody listening, if you're in a high, that only happens about 4% of the year across the country. So it's rare for your own area to get it. So if you get it, it's a problem. But after that happened, New York City looked to hire a meteorologist for their own city staff. And I wonder if you see this as a good thing, having a meteorologist work on the local or the state government level. Because on one hand, I think it's good because, you're kind of funneling all this information through one person, being the meteorologist, and then disseminating it to, let's say, elected officials. But on the other hand, I also feel like that meteorologist could then be the scapegoat and then really just getting the butt end of whatever negative could happen. So I don't know if there's any research on this, but just maybe if you don't, off the top of your head, do you see these as positives or negatives going forward?
Oh, I sympathize with your concerns. I wouldn't say there's like research specifically on this exact instance, but there is a research perspective that I can bring, and that is that we know that weather communication isn't just like the National Weather Service creating a product and then immediately reaching people wholesale, like we're just plugging into their brain and here it is. We know that, warnings and weather forecasts in general, they're not just a technology, they're a social process. This is something that in the sociology of disasters is said often. Warnings are not a technology, they're a social process. And what they mean by that is that you have information about a threat that is generated by the scientific community, and the way that it makes its way to people is through chains of other people. It makes its way through different kinds of organizations with different purview, different voices. And with the Ida, that whole conversation, that kind of view happens so often after events where the Weather Service will have a particular product or they will have said something specific, and you yet get partners or publics who come and say, well, they didn't say this was going to happen to me. And they can be expressing one of two things. They can be expressing that they actually didn't get that message, which is one layer of problem, or they can also be sometimes expressing that they just didn't feel like it really would happen to them. It's like a way of saying I just have disbelief that this actually happened to me. But they actually, if pressed, will admit that they got the message, but they just didn't fully process it for themselves. We have to sometimes get really into people's stories to understand why they're saying the things they're saying. But in light of the fact that warnings and I think broad risk communication generally, it's this set of social processes. If you have a place where they discovered, okay, there was a Weather Service product and we didn't draw it into our organizational risk management processes in the city, I think it's a great step for them to bring in somebody who can make those ties, be on point, and know all the relevant local actors and decision makers who need to know that information when they need to know it, and be part of filling in that chain where something was found to be missing.
I think that's one of the things that we've also seen in Virginia here as well. We had a very bad snow event right after the first year that shut down the interstate because of multiple accidents. The snow rate was so high, a lot of blame to go around with that. But I think for a lot of the public, and jump it if I'm wrong, Kim, but I think a lot of times the public expects more than we can actually deliver. We're a victim of our own success. There was very little, I think, that it could have been done to the disaster along Interstate 95 in Northern Virginia back in January. Maybe something could have been done, but the communications would have had to have been spectacular and it would have had to have been rapid. Can you speak to any other of those types of things, Kim, in terms of where you've seen like, wow, and I don't want to call anybody out specifically, but like, you know what, if we could nudge this or nudge this somewhere in the communications, spectrum or that relay, we might have been able to avoid this. So basically, dovetailing on Joe's question, another meteorologist in a space where decisions are being made, do you think that would be more helpful? Or is it, as we said before, it just kind of depends?
I think what we're learning is that we just need to know our partners a lot better. There's been a fundamental shift in meteorology over the last decade, especially from going from this assumption that we'll throw information out to people with a one-size-fits-all mentality. You get our schedule of products right when we put them out because we think it's meteorologically convenient to do it this way, and this is just how we've always done it, and we leave it to you to make sure that that works with your operations. And we're starting to flip that proposition on its head and look at, well, when are the local decision makers in a particular place making their calls? When do they need information by? A lot this has been implicated in, for example, in the Southeast, in freeze events, where there were, perhaps forecast products that we put out at a standardized timetable. And if they'd come out just an hour or two sooner, then there would have been schools shut down and other things avoided. And so part of the avoiding the bad outcomes is getting to know each other better. And it's again, it's about relationship. So I think what we're just needing to do is shift our focus from just the atmosphere to understanding the people who need the information about it and what is it that they need, and providing those services that they require, rather than just what we think is convenient for us to provide or what we've always provided.
Yeah, decision support is the term I've heard tossed around a lot. Being sure that the people who need the message get the message the way that they need it, so they can make the best decisions, whether it's for the public good or for private enterprise. Kim, I wanted to ask you one more time before we break. What are 2 or 3 things that you have seen in your research that might benefit the operational meteorologist, whether it's in severe weather communications, or more general practice? Right? It could be visual, verbal, written. Are there 2 or 3 things that you still see out there repeatedly? They're like, you know what, we could do better if we just X and Y here?
Making recommendations. Sometimes the space researchers can feel uncomfortable about, because we can, in the social sciences, we're still in the process of even trying to understand what all of our problems are, let alone to figure out the solutions for them. But I can offer a couple of things. One thing that I see so often in the weather community is this real hesitancy to give people forecast uncertainty information, to give them probabilities. There's sort of this belief that people can't use this information. They don't know what we mean. And it's sort of this hopelessness. And we should just give people our best guess forecast and hide everything else. And I do want our community to know that people really do need to know the envelope of possibilities so that they can plan their days. It's terrifically empowering to give people that information. When you just give them either the forecast you think they need or your best guess, just a single point forecast, you're taking out of the hands of people on the ground the ability to adapt to extremes around that could be possible. It's really putting ourselves in the driver's seat rather than other people. And with the studies that I've done with probability information, I'm able to show that even people who are low numeracy, so people who don't work with probabilities all the time, people who maybe look at numbers and feel uncomfortable, even when those people go through my experiments, they do better when they have the uncertainty information. They make better choices than when they aren't provided it, and they trust that information more, even if they're a little bit more uncomfortable with it. They can use it. What we tend to find is the real failure point of probability information is that we don't tell people the reference class. We don't tell them the probability of what. So the best example of this is our probability of precipitation product. There are a lot of meteorologists who don't even know the technical definition of this product, but in the public, they definitely don't. And the problem isn't that people don't get probabilities. The problem is that we made this reference class that is this climatology definition, comparing this day to previous days. And I mean, who in the world thinks that way? Nobody. They think that you're talking about the endemic uncertainty of this event and aspects of it. They think you're talking about the spatial coverage or what % of the day it'll be raining or something like this. We could provide that information, by the way. We could choose to change the way we do this, but we haven't, but we could. And, think about the hurricane cone of uncertainty. Same thing. People think that that's the range of places that this particular storm could go. And it's not about that. It's about our historic track error and plotting some percentage of it, like, 2 standard deviations of track error. That is just not how people naturally think about the problem. And so my recommendation for our field is just to press into all of these places where we could provide that uncertainty information and try to think about making a probability value that represents something people find useful. And if there's any big, takeaway that I'd like people to carry from this podcast, it is that is my big recommendation.
Yes, and it's going to be more and more important as we go forward in time with so many ways to communicate, so many vehicles to communicate messaging. That's going to become more important all the time. And it is a big challenge for the operational meteorologist. And I think that's one that the most of us are embracing is to try to get to that decision support and help people along with their day, tell them what's possible, what we can rule out, what we can't rule out yet, those kinds of things do have a lot of value. I've begun to come around to this idea that when you're forecasting, it isn't necessarily that you're forecasting what is going to happen, but ruling out things that aren't going to happen as we go through time. So Kim, thank you. Thank you so much for joining us today. Appreciate it so much.
Thank you so much for having me. And thank you guys for the really wonderful questions and the great discussion.
Excellent. Excellent.
Thanks a lot, Kim.
Yes, thank you, Kim. This has been very interesting. I wish we had another hour to talk with you because there's so many different things that can be discussed here. So thank you very much.
So thanks for joining us, everybody, on the Across the Sky podcast from Lee Enterprises and our colleagues in Atlantic City, Chicago, Tulsa, and here in Richmond, Virginia. And we'll see you next time. Cool.